In this video, we are going to take a look at correlation, which is another type of statistical measure that we can use to determine if there is a relationship between two variables. So the learning intention is to learn what correlation is and how it is used to show strength in variable relationships. By the end of this video, you'll hopefully know how to determine if there is a relationship between variables, put a numerical measure on the strength of this relationship, and calculate the coefficient for correlation. First of all, what is correlation? Correlation is the relationship between variables. The common aim of most research is to determine if a relationship or association between data exists, and to then create a model of it. For example, dose of drug and blood pressure, that would be something that scientists, pharmaceutical industry might want to be taking a look at. In terms of financial uses, we could look at advertising expenditure and the end of year sale figures. Is there a correlation? Does that mean the company should spend more money on advertising and so on? Have a think for yourself if there's any other examples of two different variables that you might want to work out if they're correlated, if there's a relationship between them. For example, we could consider if there's a correlation between something as simple as height and weight. When it comes to correlation, it's important that we understand different types of variables. We always have an independent variable and a dependent variable. The independent variable is the variable that's under the investigator's control. So that is something that the investigator can influence, can change, can vary. This is then denoted with X, which basically means it's on the X-axis of the graph. The dependent variable, that's the variable that you're trying to estimate or trying to predict. It's denoted with Y. So the dependent variable depends on the changes that are made in the independent variable. So for example, if we were to consider the situation from the previous example, where we have advertising expenditure and end of year sales figures, the independent variable would be advertising expenditure because the company can then alter that themselves, but the end of year sales is something that is the dependent variable. Essentially, they can't really control that because that's what the consumer controls, depending on what happens with advertising expenditure. They could then use that to hopefully predict end of year sales for a certain amount of advertising expenditure. There are two different types of correlation and some different strengths of correlation that we need to look at. Here are some types shown here with some example graphs. We've got strong and weak correlation, and we have negative and positive correlation. If we take a look at strong positive correlation, this means that the line essentially slopes up from left to right, which means as one variable increases, the other increases. That is positive correlation. If the data forms a nice linear relationship, so all the dots are quite close together on the scatter plot, that would be considered a strong positive correlation. Whereas if the dots still follow that upward trend, it's still positive, but if they're not as close together in a linear relationship, it's a weak positive correlation. Then if we look at negative, it's the opposite. As one variable increases, the other variable decreases. So we've got that slope that goes down the way. Again, strong means all the data values are quite close together and follow the linear relationship. Weak means they're not as close together. And then on the right-hand side, we've got no correlation at all. There is no clear evidence that as something happens to one variable, something happens to the other. There is no clear evidence of that. What we can do is use RStudio to calculate the correlation coefficient to determine what type of relationship we've got, positive or negative, and the strength. we use the correlation coefficient to do that. So the correlation between two numerical variables is a measure of the strength of linearity between them. It's measured on a scale that ranges from -1 to 1. A strong positive linear correlation would be close to +1, and a strong negative linear correlation would be close to -1. If there's no obvious linear relationship, then the correlation would be close to 0. Rather strangely, instead of using C to denote the correlation coefficient, it's the letter R. What we have to be careful with, though, with correlation, is that just because we have a strong correlation coefficient, that doesn't actually mean that the relationship between two variables actually exists as such. It doesn't mean that there's a causal relationship between the two variables. That means that one thing increasing doesn't necessarily cause the other to increase. For example, you might study that the number of dogs in the last 10 years that people own has increased, and the number of ice creams that people buy in the last 10 years has also increased. Those two things are clearly not actually related. However, if you were perhaps to plot those two things on a scatter plot, it may look as if they are, and RStudio would return a correlation coefficient suggesting there is a linear relationship between the two when there is in fact not. Let's take a look at RStudio and how to use the correlation coefficient there. So we've got RStudio. We are going to use the heights1 file, which contains some data on heights that have been selected and then the weights of those people. First things first, we need to attach that data onto RStudio. So we're going to, as usual, type in my data read.csv. Missed out the dash, read.csv, brackets, and it's heights1.csv with a capital that I'm using. Run. Oh, and we're getting an error message because I've not typed in .csv at the end. That's us now ran the message. So always make sure, go and double check down the bottom to make sure that you are putting in the exact same code. Easy to make a wee mistake when you're trying to do it quickly. Attach, brackets, my data, then attaches the variable names, and we run that line and it's coming up in blue. The data is now on the right hand side. We click on that. It shows us height 1 versus weight 1. To calculate the correlation coefficient between those two, we use our correlation code. Now, you can actually use two different types. On the data booklet, the one that is given is core.test. That's on the 2022 data booklet for the higher applications exam. That produces the correlation and a null hypothesis test on the data. We can use that, or we can just simply use core, C-O-R, brackets. X is the independent variable. In this case, the independent variable is height 1. So I need to make sure that I type in that exact variable name. It's popping up for me. Comma. It's weight 1. And that's coming up for me as well. Close the bracket. And if I hit run, down the bottom, it returns the correlation coefficient of 0.747. That would suggest that we have a positive correlation between height and weight, and that it's a relatively strong correlation coefficient as well. That's all we need to do to calculate the correlation coefficient. If we had typed in core.test, this would also have provided the correlation coefficient, but also a hypothesis test, which is something that we'll look at later on. So for correlation, it's simply the strength of the linear relationship between two variables. You have to consider carefully whether or not the correlation that you have is actually because there is a relationship between the two variables, or if it's just coincidental. For height and weight, we could consider that that is the case. However, in some cases, it might not necessarily be true that as one thing increases, that causes an increase in the other thing. It might just be a coincidence. So make sure that you consider that when you're carrying out any analysis using correlation.